So in this problem, we are asked to find the arc length formula. I mean the arc length of a piece of a graph of a function. So let us first recall quickly the formula. So here we have function between a and b. So this is point A, this is point B. So the point A has the coordinate A, f of A, and the point B has the coordinates B, f of B. So to find this distance, this travel distance here, this arc length, this distance, not the segment distance. This is the mistake that's very often the student will do. This is the segment distance. But we're looking at the red one, the graph. So the formula is, so the arc length from A to B, okay, along the graph is from A to B square root 1 plus the derivative of x squared dx. In general, it's extremely hard that this 1 plus f prime of x squared is a perfect square. So this is the difficulty in this integral. So sometimes it does, sometimes it does not. So let's take the example. The function is f of x equal 2/3 x squared plus 1 to the power 3/2. And we're taking x between 0 and 1. So first we need to find f prime of x. So this is 2/3, and then we take the derivative of x squared plus 1 to the power 3/2. We use the chain rule. So we have 3/2 x squared plus 1 to the power 3/2 minus 1 times the derivative of x squared plus 1, and that's 2x. So this gives me 2/3, 3/2, that's 1. So x squared plus 1 to the power 3/2 minus 1, that's 1/2. And then we have 2x. In other words, 2x square root x squared plus 1. So now we need to find the square root of 1 plus f prime of x squared. And that's square root of 1 plus, and then we have to take 2x times square root squared. So that's 2x squared times the square root squared. It cancels the square root, x squared plus 1. So if we do a little bit of algebra, that's 1 plus 4x squared times x squared plus 1. And that's 1 plus 4x squared times 1, that's 4x squared, plus 4x squared times x squared, 4x to the power 4. And here we're lucky because this is 1 plus 2x squared squared. So this is the beauty of this example. What you have inside is a perfect square, and since it is positive, this is exactly 2x squared. I'm talking about, otherwise it will be absolute value. And normally it should be absolute value, but because the inside is positive, so it's just 1 over 2x squared. So the arc length, AB, we know from the formula is equal to the integral from 0 to 1, square root of 1 plus f prime of x squared dx, which gives us, after the calculations we just did, 0 to 1 plus 2x squared dx. So the integral of 1 gives me 1. The integral of x squared gives me 1/3. So 1 plus 2/3 equals 5/3.